Today we're going to talk about Cramer's rule here. So now, Cramer's rule states that if you have a system of equations, so let's say you have a1 x here plus b1 y plus c1 z equal to d1, then we have a2 x plus b2 y plus c2 z here equal to d2 here, then a3x plus b3 y here, c3 z here equal to d3 here. Now, Cramer's rule states that if you have a system of equations like this here, then the value of x is simply equal to the determinant dx here divided by the determinant here. Then we also have y, the determinant with respect to y over the normal determinant, and the value of z simply dz over d like this here. So now, if we make a system, if from this system of equations here, if we create a matrix from what we have here, we're simply going to have a1, b1, c1, a2, b2, c2 here, a3, b3, c3 here. So here the variables we're looking for, x, y, and z like this, equal to the constants that we have this side here, d1, d2, d3 like this here. So now, the value of d here is simply equal to the determinant of this matrix that we have here. So we find the determinant a1, b1, c1, a2, b2, c2 here, a3, b3, and c3 here. Then for dx here, so the determinant with respect to the variable x that we need there. So what we do here is we replace the coefficients of x here with the constants that we have after the equal sign this side here. So meaning that where there are values of x here, we replace them with d1, d2, d3 like this here. So we're saying here we're going to have d1, b1, c1, we have d2 here, b2, c2 there, d3 here, b3, and c3 like this here. So for dx, we're saying you just replace the coefficients of x with the constants that we have after the equal sign this side here. Then the same thing goes for dy here. So here we just simply have, so the coefficients of x remain constant, the coefficients of z remain constant. What we just replace are the coefficients of y in this case. So we have a1, d1, c1 like this, a2, d2, c2 like that, a3, d3, and c3 like this. Then for dz, the coefficients of x and y remain the way they are. We just make a replacement on the coefficients of z there. So means that here we're going to have a1, b1, and d1 like this, a2, b2, and d2 there, a3, b3, and d3 like this. So Cramer's rule is basically the determinants methods. So now here, when you get the value for d here, you get the value for dx, the value for dy, and the value for dz here. So this is supposed to be dz there, and the value for dz here. So you start dividing to get the value of x here. You get the value for dx, you divide it by the determinant that you find here, it gives you the value for x. The value for y, you divide it with the determinant, you get the determinant for dy, you get the value for y here. Then z, you divide dz with d, find the value for Z there. Okay, let's look at an example now. So suppose you are taught to solve the following system of equations, where we have x plus y plus z equal to 4, and you have 2x minus 3y plus 4z equal to 33. Then you also have 3x here minus 2y minus 2z equal to 2 here. Now, if we write this here, this system of equations here in matrix form, we're simply going to have, we get the coefficient of x, 1, 2, 3 here. Then we have 1, negative 3, negative 2 here. We have 1, 4, and negative 2 here. Then this side, x, y, z here, being equated to 4, 33, and the 2 there. So now, we know that the value of x here is simply equal to dx over d here. The value of y is simply dy over d here. And the value for z, dz over d like this. Let's solve the determinant of each. Okay, let's solve the determinant for each of the following here. So for d here, we simply calculate the determinant of this matrix here. So we have 1 here, 1, 4, 1, 1, 1. Then we have 2, 3, negative 3, negative 2, 4, negative 2 like this. So here we know that that's positive for finding the determinant of a 3 by 3 matrix, negative, positive like this. So this here will be equal to 1 is the number that we have there. Then the 2 by 2 matrix that remains is negative 3, 4, negative 2, negative 2 here. So we have negative 3 here, 4, negative 2, negative 2 like this. Then minus 1 here. So it means that we close the entire row and the column where 1 is, then we get the 2 by 2 matrix that remains there. So meaning that here we're going to have 2, 4, 3, negative 2 here, plus 1 here. So we're here now. So we close the entire row here and this column here. We remain with this 2 by 2 matrix that we have here. So we have 2 here, negative 3, 3, and negative 2 like this. Now, we find the determinants of these 2 by 2 matrices here. We add and subtract whatever coefficients or whatever values we're going to get here. So here, negative 3 by negative 2 here, we're simply going to get 6 here. So we're going to say the first one, 6 minus negative 2 by 4 here, we get negative 8. Minus here, we have the 1 outside there. 2 times negative 2, we get negative 4 here. Then minus 3 times 4, we get 12 there. We close and we add this side. Then 2 times negative 2, we get negative 4 here. Minus here, 3 times negative 3, we get negative 9. Okay. So now here, this is the same as 6 plus 8, which is going to give us 4. Then here, we're going to have negative 4 minus 12, we get negative 16. Negative 16 times a negative outside here, we're going to have plus 16 here. Then this side here, negative 4 minus negative 9. So negative, negative, so that's going to be positive there. So negative 4 plus 9, we get this here. So the value for d is 35 there. So now we need to get dx. So for dx, we said we replace the coefficients of x here with the constants that we have this side here. So meaning that here we're going to have 4, 33, 2, then we have 1, negative 3, 1, 4, negative 2, negative 2 like this here. Then here we have 4 outside the brackets. Then we remain with negative 3, 4, negative 2, negative 2 here, minus 1. Then when we close this, we're going to remain with 33, 4 this side, 2 and negative 2 here, plus 1 outside the brackets there. Then we're left with 33 there, negative 3, and 2, negative 2 there, like this here. Okay, let's just cross check. So for 4 here, we remain with this 2 by 2 matrix there, which is 3, negative 3, 4, negative 2, negative 2, which is what we have there. Then for 1 here, 33, 4, 2, negative 2. Then this one here, 33, negative 3, 2 and negative 2 like that. Okay. So now we calculate the determinants here, then we add and subtract whatever we get there. So we have 4 outside the brackets here. So 3 by negative 3 by negative 2, we get 6 here, minus negative 8. Then minus here, negative 2 times 33, we get negative 66 there. So we have negative 66. Then if you multiply 2 by 4 here, we have minus 8, like this here. Then here we add again, so plus 33 by negative 2 here, we're going to get negative 66, minus negative 3 by 2, we're going to get negative 6 here. We close the side. Then if we add everything that we have here, you notice that this is simply going to be 4 multiplied by 14 here, minus this and this here, we're going to get so negative 66 minus 8, we're going to get 74 here. So 74, it becomes a positive value, so we say plus 74 like this here. Then this side here, negative 66 minus negative 6, so this becomes positive, so that's going to be negative 60 there. So now if you multiply 4 by 14 here, we're going to have 56 plus 74 minus 60 here. So if you add all these numbers here, this plus this, we're going to get 130. 130 minus 60 here, we simply get 70 there, like this here. Okay. So now let's also find dy or dy and dz there. So the value for dy here is simply equal to, we get the coefficients of x the way they are. We have 1, 2, 3 like this here. Then on the coefficients of y here, we replace them with the constants that we have after the equal sign there. So meaning that you're going to have 4, 33, 2 here. Then we maintain the coefficients of z here, which is 1, 4, and negative 2 like this. So now here we have 1 here. The 2 by 2 matrix that we're going to have is 33. Here we have a 4, 2, and negative 2 like this. Minus 4 here. The 2 by 2 matrix that we're going to have is 2, 4, a 1 outside there. We're going to remain with 2, 33 like this, 3 and 2 like this. So then here we add and subtract whatever we're going to get. So now 33 by negative 2, we get negative 66, minus 8 here, and then for this one here, negative 2, so we have a minus 4 outside the brackets there. So 2 times negative 2, we get negative 4, minus 3 times 4, we get a 12 here. Then we continue. Here we say plus 1, 2 by 2, we get 4 here, minus 3 times 33, we get 99, like this here. So if we add what's inside the brackets here, so negative 66 minus 8, we get negative 74. Then here, negative 4 minus 12, we get negative 16. Negative 16 times 4 here, we get plus 64. Then this side here, we have negative 4, and we have 4 here, minus 99, so that's going to give us minus 95 like this. So now, if you add everything that we have here, we are going to have, so there we're going to have negative 10 minus 95, we get negative 105, like this here. Okay, let's also get dz here. So for dz, we maintain the coefficients of x and y, so we have 1, 2, 3 here, then we have 1, negative 3, negative 2, then we just replace the coefficients of z with the constants after the equal sign in the equation that we created above there. So here we're going to have 4, 33, 2 like this here. We also calculate the determinant here. We keep a 1 there, then we have negative 3, 33 there, negative 2, and then 2 like this here, then minus 1. So now we remain with 2, 33, 3, and 2 here. So we have 2 here, 33, 3, 2 like this. Plus, we keep a 4 there. The 2 by 2 matrix that we remain with here is 2 here, negative 3, 3, and negative 2 here. So we have 2, negative 3, 3, and negative 2 like this. So this here is equal to negative 3 by 2 here, we get negative 6. Then negative 2 by negative 30, negative 2 by 33 here, we get, so this is minus negative 66. We close there. Minus here, 2 by 2 here, we get 4. Then 3 by 3, we get 99. So minus 99 like this here. Then plus, there's a 4 outside there. Then here, 2 times negative 2, we get negative 4. Minus 3, negative 3 times 3 here, we get negative 9. We close like this here. So let me just scroll down a bit. Now here, we have a negative 6 here, minus negative 66. So that's basically negative 6 plus 66. We're going to get 60 here. Then 60, negative 4 minus 99, we're going to get negative 95. Negative 95 by a negative here, we get plus 95 here. So it's a plus 95 like this here. Then negative 4, then minus 9. So we say negative 4 minus negative 9, so that becomes positive 9. So negative 4 plus 9, we get 5. Then 5 by 4, we get 20 here. So we say plus 20 like this here. So if we add everything that we have here, we're simply going to get so 6 plus 95, we get 155. So 155 plus 20, we get 175 here. So meaning that here we have 175 like this here. So therefore now, remember we said the value of x here is simply equal to dx over d like this here. Then what we got for dx here is 70. So I just say 70 there divided by 35, which is the value for d, which will give us 2 there. So the value of x is 2. Then we do the same thing for y. Y, I said it's dy divided by d here. So for y, we got negative 105 divided by 35. So when you divide that, simply get negative 3 here. Then for z here, say dz over the determinant there, simply equal to the value that we have is 175 divided by 35. So if you divide this into that, we simply get 5 there. So we have x here is equals to 2, y is equals to negative 3, and z is equal to 5.